Section 9.3 is about graphing rational functions. Here you see what a rational function would look like. It's a function that has a function on top and one on the bottom. When you have a fraction like that, you have to watch out for values that make the denominator 0. And those values make up what we call breaks in continuity. So when you graph these kinds of functions, you're going to be looking for breaks where the function will not be continuous. You won't be able to graph it in certain places. And there are two kinds of breaks that we're going to look for. There's a vertical asymptote and point discontinuity. Let's first talk about what an asymptote is. If you have a function, like this one right here, that simplifies, and the simplest form has a value that makes the denominator 0. Like this one, if I plug a 3 in, 3 minus 3 would give me a 0 in the denominator. If that's the case, you're going to have to draw a dotted line at that value. In this case, we draw our dotted line at x equals 3. That's called an asymptote. That means we cannot graph anything on x equals 3. So we put a dotted line there to show that we can't put any part of our graph on that spot. Now the other kind of breaks in continuity is called point discontinuity. If you have a function in which there's a 0 created on the bottom with some value, in this case -2, would create a 0 on the bottom. But if you also look at my function, it's not in simplest form. Because you see, I could cancel the x plus 2 here and the x plus 2 here and really make my function f of x equals x minus 1. So that's really what this function is. It's f of x equals x minus 1. But there is that point at which it has a 0. And so what we do in that case is we graph the function, but we just put a circle or a dot, an open circle on that one value to show that at -2 in this case, there's a point discontinuity. The function is not completely continuous because it has a hole right there. So let's review. If after it's completely simplified, there's a value that creates a 0 in the denominator, it's called an asymptote. But if a 0 is created in the denominator, but it's not there anymore once you simplify, then it's not an asymptote, it's just a circle, and we call that point discontinuity. Here we have to determine whether this equation has any vertical asymptotes or if it has any holes. The way we do that is we're going to factor the numerator and the denominator. Now the numerator is a difference of squares, so that factors into x plus 1, x minus 1. Then we'll factor the denominator by using the diamond. Two factors of 5 that add to be -6 are x minus 5 and x minus 1. Now if you look at this, you can see that to simplify this function we would cancel those two binomial factors. So the simplest version of my function is x plus 1 over x minus 5. Now because we simplify it here, we can see that if x is positive 5, there will be an asymptote, because that 5 will create a 0 once it's completely simplified. Now if we go back here, there also is a 0 value at 1, at x equals 1. But because it's not there in the simplified form, it's not an asymptote. Instead, it's going to be a hole in the graph. So vertical asymptote happens at x equals 5. A hole in the graph happens at x equals 1. So now we want to graph this function. It's completely simplified, so we can see that there's going to be an asymptote at x equals 2. So I'm going to go over to 2 and I'm going to draw a dotted line, which means my graph will never exist at x equals 2. It'll never cross over this line. So to find the graph, I'm going to make a table of values to the left and to the right and just see if I can get a sketch of what the graph looks like. So here I've made my table of values. I'm going to go to the left and to the right. Let's start to the left with a 1. If I plug a 1 in up here, I get a 1 over 1 minus 2, which is -1, and 1 over -1 is -1. If I put a 0 in, I get 0 over -2, which is 0. If I put -1 in, I'm going to get a -1 over -3, which is just going to be a 1/3, or 0.3 repeating. If I go to the right of 2, I get a 3, so that'll give me a 3 over 3 minus 2, which is 1, so that'll just give me a 3. So 3, 3. 4 over 2 gives me a 2, if I plug a 4 in. And then 5 gives me a 5 over 3, which is 1.6 repeating. So I'm just plugging values in for x and finding what their f of x is. So these dots begin to give me an idea of where my graph is going to be. Because it's never going to get to 2, I know as it passes here, it's just going to keep getting closer and closer to 2, but never actually get there, because that's what an asymptote is all about. Now I'm curious what's going to happen over here, so I'm going to put something in like negative 50. I'm just going to see what I get here. If I plug in negative 50, I get a negative 52. And if I plug that into a calculator, I get like a 0.9. So you can see that when I get way out here, I'm still getting close to the number 1. So my graph is probably going to be something like that. That's what the left side looks like. And then the right is very similar. I know it's going to get through here, but then it's never going to get all the way to 2. And then if I keep going this way, it'll look something like that. So that is the graph of this function. It's got an asymptote, and then a couple of points plugged in can help me get a sketch. Here's another example of a function to graph, but unlike the last one, this one can be simplified. So we're going to say x plus 3 and x minus 3, because the top is a difference of squares. And then now I can cancel those, leaving me a simplified function of x minus 3. So this does not have an asymptote, but it does have a hole at x equals negative 3. That's important to note, because it was negative 3 that created a 0 on the bottom, but it doesn't exist when we simplify the function. So this function is linear, so we should be able to graph that no problem. If I plug in a 0, I get a negative 3. If I plug a 2, a negative 1, and a 5 will give me a 2. So here's my graph, and I have to go back though and say that there's going to be a hole on negative 3. So right here, the graph has a hole in it because it's undefined at just that point. Everywhere else it's defined, but the hole that I found is right there.